balance. I can get started. Last week we went over parentheses balance, which starts off with you're given a string consisting of parentheses and brackets, and a string of this type is said to be correct if the string is empty, if A and B are correct, or if A or our brackets and A our parentheses is correct. So basically if our brackets and parentheses actually close properly, like they would in a program. The file contains a positive integer n and a sequence of n strings of parentheses and brackets, one string a line. A sequence of yes or no is to be outputted, depending on if it's true or not. And so our examples are these. We go into our program. I used a stack to solve this. So walking down the program, we include all our libraries. We get our variables data set, which stores how many data sets there are, and our string data, which just stores the string we're going to look over. We read in our number of strings, and then we get rid of the /n that's still in the loop. We run on to next. We grab our string. This program could be modified to run character by character, reading in each bracket and doing it that way, but I felt it was faster to just read in the entirety of the string and then process across the string, especially since then we know our size. We grab our data. The internet sucks here. We start our vector of type character. We call it stack, and we get a Boolean called failed, which will just be if we fail at any point, we stop searching, and we go down to the bottom, we say no. So we run across our string, checking each character. If it is either an empty string, which means it's correct, or it is a space, because they can have spaces between them, then we do nothing and we just ignore it. If it's an empty string, it'll fall all the way through here, and there will be nothing else to process through, and it'll just say, yes, it's correct. And that's where we come down here. If, else if it is either an opening bracket character or an opening parentheses character, an opening bracket character, we push that onto the stack. So it's just like, cool, now we know that we have an opening. If our character is of an ending type, we first check the stack size, because we're going to end up using stack.back. And if you do stack.back and there's nothing on the stack, you will get a segmentation fault error, because it's like, there's nothing for us to check. Yeah, there's nothing there. So first we check that there's something on the stack. If it's not, it fails out, because we have an ending bracket before there's an opening one. And that's an issue. And if this is true, we go on and we go, okay, if it is a closing bracket and the last thing on the stack was an opening bracket, that closes up nicely. All right, cool, we can do that. And if it's a closing bracket and thing on the top of the stack is an opening bracket, we can do that. Now, if it was the other way around, they're trying to close either an incorrect type or go into a different scope without closing, and both cases would be wrong. And we would go out and fail out here. And so it just keeps doing that. It looks for opening, it looks for closing, and otherwise it fails out. And when we get to the bottom, we just, if we failed, or if the stack still has stuff on top of it, so you had opening brackets that never got closing brackets, then we failed out. Otherwise, if it passed all the previous tests, it didn't. And you can always go on the sites here with these and go to Udebug. In fact, I recommend it. And if you want to thoroughly test your program, there's always going to be an absolutely massive data set. Like this one is over 8,000 strings. So that's actually the one I use to test my program. If we go back here, our data.dat is that same one, just massive amount of strings. And so what you do is you come here and you do copy, and it'll let you copy this automatically. So I might do like copy, go here and delete what I already have and replace it, which is actually going to be the same thing, but for example's sake. Then you'd go here and you do get accepted output, and it's going to put the accepted output there, and then you kind of run your program. And it would be preferable to output it to a file because there are limits in the terminal. So we compile it real quick. I'm so used to, I normally follow the naming convention of input.dat, but that's okay. So we do this, and we go over here.
I'm trying to learn about the DAX.
Yeah, file extensions like he was talking about today in Intro to OS are meaningless in actuality.
Well, I said I'm trying to. I'm not saying I'm being successful or anything. I thought, I was like, well, maybe this is what I need to do.
We copy our answers here, we put them in, and we go compare outputs, and it goes, whoa, your output is identical to the accepted output. We go, cool. And you can do that across all 4 of these if you want to. Normally, I pick the biggest data set, which actually technically, no, okay, it is this one by like a few. This is also another massive data set. And then these other 2 are probably small. Yeah, they're smaller data sets. Yeah, if something has a lot of downvotes, it may not actually end up being correct. And that's what the voting system's for. I'm not signed in, so I can't vote right now, though.
Whenever I use stuff like that, I always try to say thanks. If I give you thumbs up, this it filter and result.
And so normally we'd end up going in here and logging in and submitting this, but I'm actually having issues getting an account created, a new account created on Online Judge. Their system got defunded here recently, and it's been very slow ever since, sadly. But we can generally be assured that if we got it correct on all the UDebug cases, that it is correct. So now if we go on to next week's problem, we're going to do integer inquiry, which is one of the first users of BIT's new supercomputer was Chip Diller. He extended his exploration of powers of 3 to go from 0 to 33, and he explored taking various sums of those numbers. This supercomputer is great, remarked Chip. I only wish Timothy were here to see the results. Chip moved to a new apartment once one became available on the 3rd floor, the Lemon Sky Apartments on the 3rd floor. I kind of dislike questions like this because they give you a bunch of useless information that you will do nothing with. Most of what it just told us is absolutely useless. All we really need to know is what is an input and output. The input will consist of at most 100 lines of text, each of which contains a single very large integer. Each very large integer will be 100 or fewer characters in length and will only contain digits. No very large integers will be negative. The final input line will contain a single 0 on a line by itself. Your program should output the sum of the very large integers given in the output. So you take all 3 of these from our example and add them together. First, you need to find a way to store them though.